Hello, welcome to the plotline. Okay, it's take 3. Let's do this. So, we have explicitly defined fluid pipes for acid transportation. Each of these gets 4,000 aqua regia, that is 48,000 aqua regia in total, divided amongst 12 centrifuges. You need this as a primer for the entire process to start. You're not going to lose out on any aqua regia because it gets recycled through this thing. We're going to get to it later. So, our platinum byproducts are outputted into this buffer, outputs that into this nexus of item pipes. Now, copy what I have here very dutifully. So, left side is ismium and osmium. We're going to have rarest metal, iridium chloride, osmium tetroxide, and platinum sludge residue. This to the right is carbon, ruthenium tetroxide, inert metal mixture, raw palladium powder, and raw platinum powder. This one up here, output, the finalized products. This buffer exists for platinum sludge residue. After the platinum sludge is finished processing in the centrifuges, it'll be these turn. It'll be the turn of these, who will go into these and then be recovered the same way. That's why our output here has silicon dioxide and gold. So, here we have a input for iridium chloride and osmium tetroxide. Here we have an input for rarest. Here we're going to have our output bus for the osmium and iridium process. They're going to feed into here. Now, very importantly, part of the process for rarest leaves you with a iridium material you're going to have to centrifuge, which goes down here. Additionally, the very slight amount of platinum sludge residue you get from the iridium process is just going to go back here to be processed and returned into silicon dioxide and gold dust. So this is very important. You're going to need two separate, basically nexus entries for here. So this is for general usage. This is for pretty much everything. You're going to want to isolate the platinum sludge powder from the iridium process into here. Everything else just kind of goes this way. This one is important because you're not going to have enough room for the filters, but since this side is for ruthenium, palladium, and ruthenium, you can have these in order to run your ruthenium process. So, we're going to set this circuit to 1, and you're going to make fluid output go up into this input hatch. This is where your hydrochloric acid primer is contained. Because the iridium process yields you hydrochloric acid that you're going to recycle, you're going to output it, make sure it's locked into hydrochloric acid, and flow it into the same location your distillery is flowing into. Your centrifuge leads out here, and then here, this is hydrogen. Each cycle of 5,040 platinum sludge is going to need 120 hydrogen gas to process as a supplement. Here we have an output hatch for hydrogen. It goes into here. And here we have another hydrogen output hatch for byproducts from the ruthenium and rhodium process. It's going to go out here and deposit itself here. They're going to be exchanging. Now, you get water as a byproduct from osmium, but it takes a pretty long time to process all that. So, you're going to want to have a water buffer. It's water, it's basically free. Just put it here in front of an input hatch. Have an input-output hatch at the iridium process labeled for water. And that is kinda it. Yeah, I do believe that is it for the iridium process. I am powering everything from below. So I don't have to worry about anything on top. It helps with keeping it compact and saving space without having to deal with, wiring complications. The ruthenium process is a bit more complicated. You're going to have multiple output hatches, one of them right behind this electrolyzer, which outputs just rhodium sulfate. You're going to have another output hatch locked into carbon dioxide as part of the ruthenium process. It's going to go into the same electrolyzer. You will also have this output bus, which outputs everything for the process, but most importantly, separately, it's going to output ammonium chloride as part of the palladium process. All three of these liquids are going to be processed in this electrolyzer and output it up here. So, for sulfuric acid recycling, behind here, there's going to not there actually, here, there's going to be an output hatch for just sulfuric acid, because out from rhodium sulfate you're going to get sulfur trioxide, which when combined with water forms sulfuric acid. The sulfur trioxide would go in here, turn into sulfuric acid, and then just go into the very same input hatch. Hydrochloric acid is going to go right here, actually. Right here. This is where the hydrochloric acid for palladium goes. Make sure you take note of this. Let me restore this into hydrogen gas. This is going to be a dedicated bus for inert, just like there is a dedicated bus for rarest, a dedicated bus for palladium, and a dedicated bus for ruthenium tetroxide and carbon dust. So then, for your byproducts from electrolysis, you're going to filter them out like this. Up, and up goes ammonia and oxygen. You then separate them here into ammonia and oxygen separately. The ammonia from the palladium process is going to go into this electrolyzer. This electrolyzer is also fed with platinum. Out of this electrolyzer goes 4 products in total: chlorine, hydrogen, oxygen, and nitrogen. Nitrogen is going to go up top, right here. Let me try and see where I can do this correctly. Here. So, into the left goes oxygen gas. Up goes nitrogen gas. Forward into these, it's a Tetris piece of input hatches. 1, 2, 3, 4. Ordered like this. The oxygen and hydrogen are going to have very extensive buffers because you're going to get a lot of them. You're going to have a lot of leftover hydrogen at the end of this. So, you filter out your gases up here in order to finish off the process of making nitric acid. You're going to have a output hatch of nitrogen dioxide made with circuit number 3. Set any input hatch into circuit number 3 to make it. This input hatch receives nitrogen dioxide and then just spits out nitric acid here into this buffer, which spits it out down here into this mixer. You're going to have a fluid-locked nitric acid hatch up here, fluid-locked hydrochloric acid hatch down there. You're going to have up here your oxygen gas input hatch. You get your oxygen gas from over here. Over here, this innocent little one is going to be a drum filled with water so you can make nitric acid. For every 5,040 platinum sludge, you're going to want to have 252 millibuckets of water. 252,000 millibuckets of water. My apologies. So yes, that's how you finish recycling aqua regia. Output here goes up, gets uniformly split across every single machine. You're going to be very strict with the arrows here, the one directionness of the pipe, so that way you don't end up with one of them having 4,001 millibuckets and the other one having 3,999. Let's see. So, these complications. So, let me go over it again over here in case I missed it. In here, this filter extracts ammonia chloride into the electrolyzer. This extracts ruthenium tetroxide, carbon dust. This system outputs all sorts of iridium stuff, but the platinum sludge residue and the iridium metal residue goes directly into the centrifuge without having to centrifuge or store that very slight platinum residue somewhere else. Again, you're going to arrange your filter like this for outputs. This is going to be your output nexus where everything goes directly into here. This is the same spot where you inputted your platinum. Set your conveyor or robot arm into round robin, connect all these together, and just let it go. Remember to have a primer of 8,000 hydrochloric acid for the iridium and osmium process, 3,000 sulfuric acid for the ruthenium and rhodium process, 2,000 1,000, swear to God, 1,000 hydrochloric acid for the palladium process, and of course the other miscellaneous, much larger scale primers of the mandatory 120 bucket supplement of hydrogen gas, which you can just fetch easily from your excess hydrogen from recycling aqua regia. Your 420 water you're going to need for the sulfuric acid recycling, and the 252 buckets of water you're going to need for nitric acid production. In order to avoid mishaps with item transportation, make sure that your item pipes have one directionality turned on for certain locations. You can see here, we've got these two. This one has no one directionality. This one is for platinum output. It's just here for neatness. This is just for distinguishing the output from the centrifuges to the input to the rest of the array of things going on here. And that is sorta it. Yes, that's it. That's all you need to do for a compact and effective platinum process. I did this whole thing in one take with no script. I hope that was all effective. Make sure that this is set to 12, supply exact, round robin. That way everything gets 12 as it should be. Make sure to have a buffer just in case. Make sure that your distillery is set to circuit 1. Make sure that everything is in order. Make sure everything is powered effectively. Overclock these however you want. Yeah. So, if the fluid outputs just kind of bug out, break the outputs and just set them again. That happened to me before. Ensure your super tanks are not being given liquid from their output slot. So if you place this down facing this direction, it's going to have output from the back. So fix that by wrenching it into a different direction or doing it twice, and it'll just get rid of the output entirely, making it just a container. Yeah. Oh my god, I worked so hard on this. Yeah, that is a platinum line that you can do easily. Yeah, alright. Goodbye, everyone.